Ever wondered how linear algebra impacts our daily lives? Linear algebra, a fundamental branch of mathematics, is more ingrained in our everyday lives than you might initially think. It's the engine under the hood, powering a multitude of processes and systems that we often take for granted. Linear algebra is the study of linear equations and linear maps, represented in vector spaces and matrices. It's the foundation upon which many higher-level mathematical topics rest, such as differential equations, numerical analysis, and optimization. Its importance is not confined to the academic realm. It plays an essential role in fields as diverse as physics, engineering, computer science, and economics. It's at the heart of modern presentations of geometry, defining basic objects such as lines and planes. In essence, mastering linear algebra is akin to learning a universal language, one that equips individuals with the essential skills needed to navigate the complexities of the modern world. At the heart of linear algebra, we find linear equations. Linear equations, in the simplest terms, are mathematical expressions that denote a straight line when plotted on a graph. They're the mathematical equivalent of a straight path, no twists or turns, just a clear, direct line from one point to another. Each linear equation is a relationship of equality involving one or more variables. For instance, when we say 2 times a number plus 3 equals 11, we're stating a linear equation. In this, the number represented by a variable is subject to a linear operation, which when solved gives us a specific value. Now, how do these equations fit into vector spaces and matrices? Consider a vector space as a stage, and vectors are the actors. Vectors, in essence, are quantities defined by both magnitude and direction. A linear equation can be visualized as a vector in this space, pointing in a specific direction and having a certain length or magnitude. When it comes to matrices, things get a bit more interesting. Matrices are like containers that can hold these vectors. A matrix can represent a system of linear equations, with each row corresponding to a different equation. Solving a matrix, therefore, is like finding a solution that satisfies all these equations simultaneously. Essentially, a matrix is a compact way to keep track of a whole bunch of linear equations all at once. It's like having a tidy little filing system for your equations, where each one has its place, and you can easily find the solution you need. In the grand scheme of linear algebra, linear equations are fundamental. They are the building blocks, the foundation stones, if you will, on which the entire field is built. They allow us to explore relationships, solve problems, and understand the world in a linear, straightforward way. So whether you're dealing with a single equation or a complex system of them, remember that each linear equation is a piece of the bigger picture. Every equation is a thread in the intricate tapestry of linear algebra. Linear equations are fundamental tools in linear algebra, helping us make sense of complex problems. Another cornerstone of linear algebra is linear maps. These are mathematical functions that carry points from one vector space to another, respecting the linear structure of the spaces. In simpler terms, they take inputs, process them in a specific way, and produce outputs. Linear maps can be as simple as multiplying by a constant, or as complex as a multi-step process involving various mathematical operations. The beauty of linear maps is that they can be used to represent a wide variety of real-world phenomena. Let's delve a bit deeper. Imagine a function that takes vectors as inputs and produces vectors as outputs. This function is considered a linear map if it follows 2 rules. First, the direction of scaling. If we scale the input, the output scales by the same factor. Second, the direction of addition. If we add 2 input vectors, the output is the same as if we added the outputs of the 2 vectors separately. Now you might be wondering, why should we care about linear maps? Well, they are everywhere. In physics, they're used to describe transformations in space, like rotations. In engineering, they're used in signal processing and control systems. In computer science, they're used in computer graphics to transform images. And in economics, they're used to model economic systems. For instance, in physics, the concept of linear maps is used to describe how an object moves in space. If you've ever played a video game, you've seen linear maps in action. They're used to transform the position of characters and objects in the game's world. In economics, linear maps can represent production functions. These functions show how different inputs, like labor and capital, result in different levels of output. This helps economists understand how changes in the inputs affect the output, which is crucial for decision-making in businesses and economies. So, as you can see, linear maps are not just abstract mathematical concepts. They have real-world applications and are used in various fields to solve complex problems. Linear maps, like linear equations, are key to understanding and applying linear algebra. They provide us with the tools we need to navigate the complexities of the world around us. From the smallest particles to the largest economies, linear maps help us make sense of it all. Linear algebra is not just for mathematicians. It's a fundamental step in a student's mathematical journey. This powerful branch of mathematics is often introduced as a subfield, a stepping stone towards understanding more complex mathematical principles. But what's the secret to teaching linear algebra effectively? First, we need to acknowledge that linear algebra is not a standalone subject. It's a thread that weaves through various disciplines, from physics and engineering to computer science and economics. Therefore, making connections between linear algebra and real-world applications is key. By doing this, we can help students see the relevance and practicality of the subject, sparking their interest and fostering their engagement. Secondly, teaching linear algebra is about more than just equations and matrices. It's about developing critical thinking and analytical skills. How do we do this? By promoting an environment that encourages curiosity, discovery, and problem-solving. It's about challenging students to think outside the box, to question the why behind the what. This approach not only enhances their understanding of linear algebra, but also equips them with valuable life skills. In addition, the use of creative and interactive teaching methods is instrumental. This could be through the use of technology, like digital tools and software, or through hands-on activities and collaborative projects. By making the learning process dynamic and engaging, we can ensure that students not only grasp the fundamental concepts, but also retain them in the long run. Lastly, we need to emphasize the importance of practice. Mastery in linear algebra doesn't come overnight. It requires consistent effort, perseverance, and a lot of practice. This is where educators play a crucial role, providing guidance, feedback, and encouragement to help students navigate their learning journey. In essence, teaching linear algebra is about guiding students to see the bigger picture, to understand the intricate connections between mathematical concepts, and to appreciate the beauty of mathematics. Mastering linear algebra is integral to a comprehensive and effective mathematics education. But how does linear algebra affect us in our daily lives? That's a question many of us have asked, and the answer might surprise you. Linear algebra is like the invisible math magician, quietly working behind the scenes to make our everyday lives function more smoothly. Let's start with an example most of us can relate to, using GPS to navigate our way to a new destination. Linear algebra comes into play here, as it's the mathematical muscle behind the computations that help determine the shortest or most efficient route from point A to point B. Or consider when we're shopping online. Ever wondered how websites seem to know exactly what product recommendations to make? That's linear algebra at work too. It's responsible for the algorithms that analyze our shopping habits and suggest products we might like. And let's not forget about the world of entertainment. When you're binge-watching your favorite series on a streaming platform, linear algebra is right there, powering the recommendation engine that suggests what you should watch next based on your viewing history. Moving on to a more traditional application, we find linear algebra in modern presentations of geometry. It shapes and defines basic objects such as lines and planes, helping architects design buildings, engineers construct bridges, and video game developers create realistic virtual worlds. Even in the world of health and medicine, linear algebra is a vital player. It's used to model and analyze medical images, helping doctors diagnose illnesses and plan treatments, and that's just scratching the surface. From economics to physics to computer science, linear algebra is a fundamental tool that helps solve complex problems and make sense of the world around us. So the next time you use your GPS, shop online, or watch a movie, remember the unseen hero working behind the scenes? So, linear algebra isn't some abstract branch of mathematics. It's a tool we use every day, whether we realize it or not. So, we've seen that linear algebra is more than just a subject in school. It's a fundamental branch of mathematics that's deeply intertwined with our daily lives. From the basic principles of linear equations to the complexities of linear maps, we've journeyed through a subject that is the cornerstone of advanced mathematical concepts. Linear algebra is essential in various fields like physics, engineering, computer science, and economics. It's not just about solving equations, it's about understanding the patterns and structures that govern our world. In education, it's a crucial stepping stone that equips students with the necessary skills for more complex mathematical principles, fostering critical thinking and analytical prowess. So whether we're calculating the shortest route home or designing a skyscraper, linear algebra is there, working behind the scenes, making sense of our world. Remember, linear algebra is not just about numbers and equations, it's about understanding the world around us.